This is HOLI Byte, a podcast series from the Hands On Learning Initiative. In this bite, Gayathri tells us about stellar evolution, the life story of stars.
Stars are like fiery hot balls of gas
held together as one massive globule with the help of gravity. Like humans, they are born, have a finite lifetime during which they age, and finally die. The initial mass with which a particular star is born decides how it evolves. Take, for example, a star like the Sun, whose mass is roughly 2 times 10 to the power 30 kg, that is, 2 followed by 30 zeros. It fuses hydrogen to helium for a few billion years. During this period, gravity tries pulling all the matter inwards, while radiation from burning hydrogen exerts pressure outwards, that is, in a direction opposite to that of gravity. The burning of hydrogen keeps the tug of war between gravity and radiation going. As the amount of hydrogen starts decreasing, the star grows into a massive red giant. As the name suggests, the star has a reddish color and grows in size because of the thin layer of hydrogen that surrounds a small helium core. In fact, when our sun becomes a red giant, it will grow so big in size that it will engulf all the inner planets of the solar system, including the Earth. After all the hydrogen fuel gets exhausted, gravity starts overpowering the outward radiation pressure, making the ball of gas collapse on itself. This is when things start getting exciting and stellar fates diverge. For sun-sized stars, the core starts collapsing while the outer shell starts expanding and is eventually blown away, leaving behind a white dwarf star that is hot, less luminous, and nearly the size of the Earth. For stars born with roughly twice the mass of our Sun, the cores collapse further. They undergo a massive explosion called a supernova and end up as neutron stars that are roughly the size of a small city with a 10-kilometer radius. A different kind of pressure, called the Fermi degeneracy pressure, exerted by fermions that are particles like electrons and neutrons, prevent white dwarfs and neutron stars from collapsing further. But what if there is a star that is really massive? Such stars, with masses many times the mass of our Sun, explode brilliantly and finally form a black hole. No kind of pressure can counter gravity in black holes. Even light, or more generally, electromagnetic radiation, cannot escape from these notorious objects.
When you look up at the night sky and see the countless number of stars, remember each star has its own story.